All right, so a couple of things to add on to with our discussion of ionic compounds. The first deals with metals that can actually form more than one cation. When we sort of look at the metals in the A groups, 1A, 2A, 3A, essentially those metals can only form one type of ion. And that is why we can use the group number to predict what ion they are going to form. What makes the B group elements different, and remember the B group elements are your transition elements, they are all metals. One of the things that makes them different from the A group metals is that most of the B group metals tend to form more than one cation. In other words, they form ions with different charges. The exceptions for that are zinc, which only forms a +2 ion, cadmium, which only forms a +2 ion, and silver, which only forms a +1 ion. So remember your transition elements. And let's see if we can write that a little bit better on the bottom. Your transition elements are your B group elements. So the biggest difference in terms of the name of an ionic compound that contains an A group metal versus a B group metal is that when we have an ionic compound that contains a B group metal, we have to identify the charge that that ion is going to have. So when the name of an ionic compound involves a B group metal, we indicate the charge of the metal ion in the name. Now, how do we do that? The way that we do that, is we use a Roman numeral next to the name of the element, next to the name of the ion, because it's still the name of a metal ion, whether it's an A group metal or a B group metal. The name of a metal ion is the element name itself. But what we're going to do here instead, and let's just erase some of this a little bit, is that when you have one of these B group metals, except for outside of zinc, cadmium, and silver, we're going to give the charge as a Roman numeral next to the ion name of the metal, which is the same as the element name. So if you have copper with a 2+ charge, in the name you would write copper Roman numeral 2. And you put the Roman numeral in parentheses as well. Copper with a +1 charge, copper 1. Iron with a +2 charge, iron 2. Iron with a +3 charge, iron 3, so forth and so on. Okay, so here's some more examples of metals that have multiple charges: chromium, cobalt, copper, gold, iron. Do you have to memorize what ions each of these are going to form? No, you don't have to memorize that. You don't have to know that cobalt is going to form +2, +3. The only thing you really have to remember, in a sense, is that for zinc, cadmium, and silver, you would not use a Roman numeral in the name because, like the A group elements, they tend to form only one type of ion. I guess for me, if you put the Roman numeral in, it might not be the end of the world, but if you have a multiple choice question or something along those lines, you're not going to see the Roman numeral there. So you really do have to remember that for zinc, it's +2. For cadmium, it's +2. And for silver, it is +1. Okay. So determination of variable charge. So basically what they want to do here is they want us to come up with the name of this compound. Use the charge on the anion and charge balance to calculate the charge of the metal ion. And essentially we need to do this in order to come up with the correct name. And you'll see what I mean in a moment. So here you have a compound MnF2. Mn is the chemical symbol for manganese. Now, if you take a look at where manganese is in the periodic table, manganese is part of or is one of the B group metals. So as part of the name, I'm going to have to put a Roman numeral indicating the charge of the manganese. Now, in essence, I don't know exactly what that is yet, but I'm going to show you how to figure it out. And then F, of course, is fluorine, but we know that our non-metal ions, our anions, end in IDE. So we would write that as fluoride. Now, how do we figure out the charge of the manganese? Based on the chemical formula, how many manganese ions are there? Well, there's one, because there's no number next to the Mn, so that means there's one of them. Based on the chemical formula, how many fluoride ions are there? There's two, F2. And we know the charge of each of those fluoride ions. Because fluorine is in group 17 or 7A, they have to have a -1 charge. So how do we know what the charge of the manganese is going to be? We know that for all compounds, at the end of the day, the sum of the charges has to add up to what? 0. So if you have -2 for the two fluorines, -1 is -2, the manganese has to be +2. Because now the overall charge adds to 0. And you would have manganese 2 fluoride. Okay. Again, just to give you an example of another slide that contains, metals that have a single charge, metals that have a multiple charges, and then non-metals don't form more than one charge, essentially. Non-metals tend to form ions, only one type of ion, just like the A group metals. So, that's why we can, again, make the predictions for the A group elements. And again, you don't have to memorize this table. For the A group elements, you have to remember those trends. And then for the transition elements, of course, you want to remember zinc, silver, and cadmium. All right. So we did naming compounds with variable charge metals, determine the charge of the cation from the anion, name the cation by its element name and use the Roman numeral in parentheses for the charge, name the anion by using the first syllable of its element name followed by IDE, name it with an IDE ending, write the name of the cation first and the name of the anion second. All right. So here's another example of that. Name the ionic compound FeCl2. So Fe is the chemical symbol for iron. Iron is part of the B group metals. So in the name, we're going to have to indicate the charge. We don't know what it is yet. And then Cl, of course, is chlorine, but the anion name would be chloride. So this would be iron something chloride. Let's figure out what the charge here is of the iron ion that's present, because if I look at the chemical formula, there's only one iron ion, Fe, with no number means 1. Based on the chemical formula, there are 2 chloride ions. And because they are also in group 17 or 7A, each one of them is going to have a -1 charge. So again, that adds up to -2. I have 1 iron ion, and in order for the overall charge to add to 0, this would have to be +2. So what you would have here is iron 2 chloride. Okay, just to show you, if you had FeCl3, most of the name would be exactly the same. But now, even though there's still 1 iron ion, now there's 3, based on the chemical formula, there are 3 chloride ions. So now, what would the charge of the iron ion have to be? It would have to be +3. And this would be known as iron 3 chloride. So that's why just writing down iron chloride itself would not be acceptable, because there's FeCl2 and there's FeCl3. Which sort of version of iron chloride are you looking at? And that's why you have to, for these transition metals, in the name, you have to give a Roman numeral indicating the charge. Okay. Now, we haven't gone the other way yet. Let's take a look at giving the formula for chromium 3 bromide. So chromium has the chemical symbol of Cr. It's a metal. It's a B group metal, but it's a metal. So the charge has to be positive, and the Roman numeral next to the name gives us the charge. So the charge on the chromium here would be +3. And again, I know it has to be positive because this substance is a metal. Bromide, of course, refers to what? Bromine. And we know because bromine is in group 17 or 7A in the periodic table, that the bromine is going to have a -1 charge. So as it stands right now, if you have one of each, does the overall charge add to 0? And the answer is no. In order to get the overall charge to add to 0, I need a total of 3 bromide ions, because now I have +3, -1, -2, -3. Now the charge adds up to 0. And the chemical formula that leads me to is CrBr3. 1 chromium, 3 bromides, CrBr3. Okay. A couple of other examples to finish off. Okay. First one, SnO2, we want to give the name. Sn is the chemical symbol for tin. Tin is a transition element, a transition metal. So we're going to have to get the charge as part of the name. O, of course, represents oxygen, but here, of course, it would represent what? It would represent oxide. So what we have here is tin something oxide. How do we figure out what the charge of the tin is? Well, based on the chemical formula, there's 1 tin ion. Based on the chemical formula, there are 2 oxygen or oxide ions. We know that because oxygen is in group 16 or 6A in the periodic table, oxygen is going to have a -2 charge. So this adds up to -4. And because I only have 1 tin ion, the charge of the tin ion actually has to be +4. And therefore, this would be tin 4 oxide. Okay. One more example. Now we have a name. Let's come up with a chemical formula. Cobalt 2 nitride. So cobalt, chemical symbol of Co. It's a metal, so the charge has to be positive. And the charge of cobalt in this case is 2. They're telling us that, okay, because it's a B group metal. So this would be cobalt +2. Nitride represents nitrogen. And the nitride ion has a charge of -3. It's in group 5A. And elements of nonmetals in group 5A have a -3 charge. So right now, if you have one of each, does the overall charge add to 0? And the answer is no. Again, we come across the situation of one having a 2 and one having a 3. And the number that we want to essentially reach for both of them in terms of charge is 6. +6, -6, because then that would add to 0. So to get to that, I need 3 cobalt ions total. And I would need 2 nitrogen or nitride ions total. Because if I do, now I have +6 and -6, and that adds up to 0. So the chemical formula here would be CO3N2. Let me just write that O a little bit better. It definitely should not be capitalized, that's for sure. But I would have, and I don't even like that so much. So let's try that one more time. And then the video will be over. CO3N2. That's good.